All right, Year 12 mathematicians, we're going to have a look at our graph sketching skills today, often a bit of a patchy one for lots of students. I'm going to try and get those on point. So we're going to look at sketching specifically polynomials and making sure we understand the different rules we need to follow depending on what form our polynomial takes and what it looks like when we're trying to sketch it. So job number one with polynomials is to understand what happens when you have different combinations of roots, because that's going to form the basis of our sketch. Okay? So when we say we have a single root, it means it comes from a bracket where there's no power on that, it's just a single bracket on its own. So if we kind of glance ahead, we can see a single bracket here, we can see a single bracket here. So when we get brackets like that and a root comes out of it, for those single roots, it is just going to cut the x-axis. So it just goes straight through the x-axis, out the other side, right? So that's what happens with our single roots, nice and simple. For our double roots, so double roots come from brackets where there's a squared on it, like this sort of one here. So if we have a double root, it's going to rebound off the x-axis. Okay, there's other ways you can say that. You can say the x-axis is a tangent. Some will say it just touches the x-axis, but it's going to rebound off the x-axis when we have our double roots or squared brackets. For a triple root, this is your less common one. Lots of people aren't necessarily sure what happens with a triple root. We end up with something called a stationary point. Heard of that? Of inflection. Might not have heard of that. So, what does that mean? So a stationary point of inflection, stationary point is as it sounds. We're used to finding stationary points for curves, so for quadratics, for cubics. So that's where, as we go up, potentially, or come down, we get to a point where the curve goes flat, right? That's a stationary point. Now what we're very used to is that those stationary points are in fact turning points. So our graph then turns and comes back down the other way. Okay, that's not what happens here. So our stationary point goes flat, just like the same as if it was going to turn, but then instead of turning, it then carries back on, going the same upward slope that it had before. Okay, so this is a stationary point of inflection. That is what happens when you have a triple root, so a bracket with a cubed on it. All right, so if we understand those, you can sketch any combination of polynomials, right? So you can go beyond quartics, you do quintics and stuff like that if you want to, but quartics is the maximum that we go up to for A-level maths. Okay, so let's see if we can put that into practice and sketch ourselves a couple of polynomials. So first one here, y equals x minus 2 squared x plus 3. So job number one, I have an x here that's in a squared bracket and another x here, so that means it's a cubic graph. So it's a cubic. Make a note of that first. This x is positive, square it, still positive. When I take this x here, still positive, so it's a positive cubic. So our shape is going to be our bottom left to top right, up down, up type shape for a cubic graph. Okay? We then want to make a note of the roots. Okay, so they're the ones that come out of our brackets. So if we check our brackets, we've got 2 and minus 3, right? So the ones that would make the bracket 0. So we've got 2, minus 3, and I need to make a note so I don't forget that this 2, right, when I've solved this and got my value of 2, has come from a squared bracket. So it is a double root. Okay, because then I need to make sure that I follow my rules that I came up with up there. And then I'd quite like to know my y-intercept, because that's a useful point to then aim for on my axes and can sometimes tell you if you've got something slightly wrong if you get your y-intercept. So y-intercept, remember, x equals 0. Sub x equals 0 and see what we get. So if I put 0 here, I get minus 2 squared, which is 4, times 0 is here, so I get 3. So 4 times 3 gets me 12. So here's my checklist of things I need to make sure happen on my sketch. Now we just got to do it. So I'm going to put on my 2 somewhere over here, minus 3, mark it somewhere over here. Y-intercept of 12, again we can put that somewhere over here. So now we're going to go from our bottom left to top right, so starting down in this quadrant here, we're going to come up through the minus 3, then we're going to go through the 12. So now remembering what's going to happen at this 2, it's going to rebound off the x-axis. So as I come down to the 2, I need to make sure I just touch the x-axis and rebound off, and there is my cubic sketched, right? With roots 2, repeated root, does the rebound. Minus 3, cuts through, straight through the x-axis. Y-intercept is 12, positive shape, done. Okay? So what happens when we move up in our powers? So if we skim through this one, we've got an x here and it's cubed. Then we've got another x here, so this is a quartic. So So we make a note and say, right, it's a quartic polynomial we're going to try and sketch, and then we have another check or do it at the same time. This is positive x, qubit's still positive, but this is a minus x. So that would make it minus x to the 4, so it's a negative quartic. Now we need to know our shapes. So negative quartic generally is the M-type shape. Now there's lots of variations of that. This isn't going to look much like an M when we've finished, but the main idea is that our tails go down into the negative part. That's for a negative quartic. All right. For a positive quartic, if we had one, more like a W shape. They go up into the positive part. So we've got a quartic. We're going to write down our roots. So we've got -1 coming out of this bracket, and then +4. Now lots of students get this wrong. When you put the other way around and write 4 minus x, lots of students say, oh, well, that must mean it's x equals -4 from this bracket. It's not. It's still 4. If you're ever not sure, write down your little equation, right? We're trying to make 4 minus x equals 0. Move the x across. +4, right? So 4 is another root. Add that to our list. And then we make sure we remember this -1 that came from this one did have a cube on it. It is a triple root. So this one's a triple. So we need to make sure we account for our triple rules when we start to sketch. All right, y-intercept still helpful. So if I do x equals 0, I get 1 for this one, qubit still 1, and then 0 here means there's only a 4, so 1 times 4, and I get 4 for my y-intercept. So that's all the information I need. I've got my shape, roots, and the y-intercept. Transfer those to the axes. So my y-intercept of 4, put somewhere around there, -1, put somewhere around there, and then 4 somewhere around there, right? So now we're trying to fit, remember, this sort of shape, right? It's not exactly that, but that sort of shape. So starting in the bottom left and finishing in the bottom right, through these points, making sure we get that stationary point of inflection at -1. So quite a lot going on. So we're going to start down here in our bottom left. We're coming up to the -1. This is where we then want our stationary point of inflection. So I'm not turning. I'm going to carry back on up through 4 over here. Now I'm going to turn because I need to go through this 4 over here and then cut because it was just a single root through that 4. Try to make sure I get through it and down. So I've got my negative tails. Not much like an M shape, but you can kind of see the idea of where the M comes from with our stationary point of inflection and our y-intercept and roots all marked on. Okay, so once you are happy with how your curve behaves with these different combinations of roots, it becomes a much, much simpler process. Okay, so you can extend that into quintics and beyond if you really want to, or you can have a go at sketching lots of different combinations of cubics and quartics with lots of different roots. All right, let me know in the comments how you get on. Hit that like and subscribe for more help with your Year 12 maths content.